Okay, in this tutorial I'm going to show you how to model the circuit that I've shown you on the PowerPoint here, where we're going to be building just a simple resistor capacitor network, which is going to then give a discharge into this LED. And the reason we're doing this is we want to work out what the time constant is for the capacitor, and then the effect that that time constant has on the LED. And then once you built this, you're going to play around with the values of R1 and C1 and record down the effects that it has on the LED there. Okay, so the first things we need to do is we need to get our 9 volts and 0 volts rails in. So to do that, we're just going to go onto Yenka, get a new document open, and we go electronic components, basic components there, symbolic, and we can put a battery. We can put either a battery in, or we can, if you find might be in lab power supplies, we'll have a quick power supplies. Voltage rail goes in there, and 0 volts goes down there. Try and keep them neatly arranged so they are vertically above each other and space them apart nicely. Okay, so we've got those in. The next thing we need to do, if we go back to that, is we need to put our little SPST switch in. So we can go back there, let's close that folder there, and we go input switches SPST, just drag that in, and connect that to 0 volts by just clicking and dragging to the 9 volt rail. Okay, the next one, let's get our resistors in and the capacitors. So we're just getting a simple resistor down there. Now, annoyingly, I don't know why resistor is included in switches there, but annoyingly it's not actually with the resistors on there, so we need to find symbolic, and it's not in some basic components either. So what this is described as is actually it's an analog component. So it's going to be in passive components. We're getting an electrolytic capacitor. Just drag that down there like that, and now we can connect the top up there, and we can connect the resistor to the capacitor and the capacitor to 0 volts. So you can see there's the first loop of our parallel circuit done. These two are in series, obviously. So if we now go to the next part of the circuit, we've now got a potential divider coming out here, which is going to link to R2. We're going to put this component in. We've not learned about this one yet. It's called a transistor, so we're going to put that in as well. So let's go back to basic components. In fact, even easier is if you click on the resistor or any components, you go Control C and then go Control V. You can then copy and paste components quite simply. You click on that little grey dot to rotate them around. Okay, so here's our potential divider. So we're getting the V out that's coming from between the resistor and the capacitor. So remember, a potential divider is where two components divide the voltage to a certain proportion. So the V out here will be a certain division between the resistance of this component and that component there. Let's get our transistor in now. So you need to close that and go discrete semiconductors, and you're getting an NPN transistor. We're going to connect the base of the transistor, which is this one here, next to that black line, vertical line there. We're going to connect that to the R2, and then let's just go back to a circuit. And we're going to connect this part called the collector up to plus volts, and then we're going to put in our LED now. So we need to go outputs, light, and then get yourself a light emitting diode and put that onto the emitter leg of the LED, of the transistor, sorry. Now if we leave that as it is, obviously we haven't got a protection resistor in for the LED yet, so we need to do that now. So let's drag a new resistor in and rotate that around so it's in line, and there we are. We can now connect that up to 0 volts and connect that to the other end of the LED. Now a good value for a protection LED is just 330 ohms, so just type in 330 there, hit return, and that's enough just to protect that LED to stop the current flowing too fast through it. Okay, so we've got our circuit in place now. So what you now need to do is, you've got the capacitor and you've got the R1 there. When these are the same, if we just have a fairly small value in C1 first, when we turn on the SPST switch, you'll see that the LED slowly glows up and gets to its full brightness, and then when we release the switch again, it goes off pretty quickly. So the charge up as it's charging, and then the charge down. Now obviously at the moment the resistor here is controlling how fast this capacitor is charging. So what I'd like you to do in the table on your sheets is type in some different combinations of R1 and C1, and then see the effect that it has on the LED's charge time and discharge time. So if we put in a much greater value on C1, if we put in 800 microfarads there, and then we turn this on, you'll see not a lot happens to start with, and it does take a while for us to see anything actually happening there on the LED. So you can see now it's slowly glowing up. If we hover over, we can see that the current is slowly increasing across the LED there, so then it's gradually brightening. And then when we release the SPST switch, it actually goes down very quickly, and we just saw there's a little red dot just left there, and you can see the current still falling. So what happens there is the capacitor is actually still discharging through that LED, and because it's quite a large one, it does take quite a long time to discharge. So I'd like you to build this circuit and then replace the values in for, say, four to six different combinations, and just record your observations of what happens to the LED there. Okay, if you get to the end of that, well done, and when you've finished all those recordings, move on to the next tutorial.